Hi there and welcome to the first Atomo Tutorials video where we're looking at some of the fundamental concepts in chemistry for topic 1. This topic and especially this first video are very important because they contain content which sort of underpins much of the rest of the material in this course. And I actually think that by knowing the key concepts such as the atomic structure and knowing them really well will make the rest of the course slightly easier. So we're going to start off by looking at the atomic structure. All matter is made up of these tiny structures called atoms, and they are incredibly small with an approximate radius of 1 times 10 to the power of minus 10 meters. And in case you're not familiar with standard form, that is the same as writing 0.00 with 9 more zeros after this decimal point and then a 1 in meters, which is an incredibly small number. But the atom itself is made up of even smaller particles called subatomic particles, and the diagram shown here represents the nuclear model of the atom. At the center of the atom we have this thing called the nucleus, and the nucleus contains 2 of these subatomic particles, protons and neutrons. Protons have a positive charge and neutrons have no overall charge. They are neutral. And because we have a nucleus which contains positive subatomic particles and neutral ones, the overall charge of the nucleus is positive. The last subatomic particles are called electrons. Electrons are negatively charged and they move in orbit surrounding the nucleus and are contained in these things called electron shells, which can also be referred to as energy levels. But what's really quite fascinating is the size of the nucleus is actually tiny compared to the whole atom. This diagram is definitely not representative of the true scale. In reality, the nucleus has a radius about 1 in 10,000 of the length of the whole atom's radius. In other words, if you were to multiply the approximate radius of the atom by 0.0001, this would give you the approximate radius of the nucleus. And as a result of this, most of the atom is actually empty space, and I think a more realistic way to think about the size of the nucleus compared to the overall atom's size is to imagine a marble placed on a kickoff spot in a football stadium, with the marble representing the nucleus and the stands at the top of the stadium representing the electron shells. So if we go into some more detail about the subatomic particles, protons have a relative charge of +1, electrons -1, and neutrons have no overall charge, they're neutral. It's also important to note the relative masses of these three. And the relative mass isn't given with any units, it's not measured in grams or anything like that. The relative mass measures mass on a scale where a proton or a neutron is 1. And this might sound confusing, but protons and neutrons have the same mass effectively, so we give them the same number, 1. But the mass of an electron compared to or relative to the mass of a proton or a neutron, because they have the same mass, is 1 in 2000, or 0.0005. So you would need, in other words, 2000 electrons to equal the mass of a single proton or a single neutron. And I'd like to talk a little bit more about relative charge. So atoms are, by definition, neutral particles. And this means that atoms always have the same number of protons and electrons. So for this particular atom we have 2 positively charged protons at the nucleus and 2 negatively charged electrons in the surrounding electron shells, and this balances out the overall charge to 0. The moment we have an imbalance in the number of these particles, so if we had one extra electron, we would have an overall charge of -1, and we would be going from an atom to an ion. And an ion is a charged atom, or a group of atoms having lost or gained electrons, and this is something we will look at in much more detail within this topic. But for now, just remember that atoms are neutral, and they have equal numbers of protons and electrons to balance out the charge. Now, to finish off this first tutorial, I'm going to introduce the nuclear symbol. And there are nuclear symbols for the many different atoms that exist. This one's for carbon, and these symbols give us some important information regarding an atom, such as the chemical symbol, the name of the atom, and two important numbers. The first one, which is seen at the bottom of the nuclear symbol, usually is the atomic number, and the other number is known as the mass number. The atomic number tells us the number of protons contained within the atom, and the mass number tells us the number of protons plus the number of neutrons that we have in that same atom. And the reason the mass number tells us, or the reason the mass number is made up of the number of protons and neutrons, is if you think back to when we were looking at the relative mass, protons and neutrons are effectively the heavy subatomic particles when we compare them to electrons, and they're contained at the nucleus, both of them. And so as a result, the vast majority of the atom's mass is concentrated in the nucleus, and that's why we use the mass number for counting up those two. But actually, from these two numbers, we can determine how many of each subatomic particle there is in an atom. So if we use this example, carbon, and we try and work out protons, neutrons, and electrons, we know how many protons there are because it tells us straight away, 6. That's the atomic number. There's also 6 electrons, because if you think back to when we were looking at why an atom is neutral, it's neutral because we have the same number of protons and electrons. So the atomic number tells us the number of electrons as well in an atom. As for the neutrons, we're given a number telling us the number of protons and the number of neutrons, and then a separate number telling us the number of protons. So actually, if we take away the atomic number from the mass number, we will be given a number of neutrons. In this case, 12 minus 6, which is 6. And that is how we can use the atomic number and the mass number to work out how many protons, neutrons, and electrons there are in an atom, literally using this guide here.